Hi, my name is Wade Loudermilk. I am the Chief Technology Officer of TEVET, and with me is Mr. Kevin Greeley. He is a consultant to TEVET, and he is a retired uh, pilot and backseater with an expertise in weapons and electromagnetic warfare systems. And today, what we're going to do is we're going to share with you our Liberty Electromagnetic Warfare System, or Liberty EW. And we would like to talk to Kevin about what he thinks about this product. So, Kevin, you've been looking at the system for quite a while. Please give us your insights into the system.
Well, over 3 decades of service flying older aircraft like F-4s and newer aircraft like MC-130s, we've seen a continuous evolution in the complexity of our adversary systems and our own, and it's always put a high demand on test and evaluation to really know, are we ready to go into a combat condition and not have any surprises on the first day. The demand has always been higher channel count, higher bandwidth, faster measurement time, and of course record and playback to archive important data for repeat analysis. This sort of illustration is very visual to the aircrew or engineer to represent the spectrum and as big as we need it, and then to perform record and playback, especially the record triggers with pre-record time, so that preamble events in a threat engagement can also be captured and recorded. This sort of information is essential not just to engineering test and analysis, but even for aircrew training of where we're at and what we would do with our own systems and our own protection. Could you tell us a little bit about the record and playback?
Well, what you're looking at here is what we call the real-time spectrum analyzer. It is a multi-channel real-time spectrum analyzer. It has 4 channels in this configuration. And we have 2 ways that you can record and record data. You can either do that through the real-time spectrum analyzer, or we have a dedicated application that allows you to accomplish the same thing. In the real-time spectrum analyzer, what you're looking at is in the upper left plot is what we refer to as a waterfall display or a spectrogram. In the upper right is a histogram. Lower left is a spectrum. And then in the lower right is the time domain data that we have actually captured. This is a very intuitive device. There are 4 real-time spectrum analyzers running concurrently that you can actually control through an application programming interface, which is compatible with Python, C, C++, C Sharp, MATLAB, and also LabVIEW. So when you look at the instrument, if I come up and basically select the wrench, that allows you to change the parameters on the instrument. So you can see channel 0, channel 1, channel 2, and channel 3. So I can control each one of the channels. What you see also is that we have separated the capture parameters, which is associated with the RF record, with the analysis parameters. And the reason we do that is that typical real-time spectrum analyzers, they have the capture bandwidth equal to the analysis bandwidth, which could match signals. So we decoupled the analysis from the capture settings that allow you to control the capture parameters and then independently control the capture parameters. By making the analysis bandwidth smaller than the capture, you're able to improve the minimum detectable signal. And when the system detects, depending on how you configure it, when the RTSA detects a trigger event, it will then generate a trigger causing all 4 channels to be able to stream. And so I can do that. If I come in and change and look at the record tab, this allows you to set up the pre-trigger time that Kevin mentioned, the post-trigger time, and the duration of the instrument itself. In addition to that, we can control the spectrogram. So you can control the sweep period of the spectrogram, the number of frames that are in the display, and also the number of frames that are stored. I can also control the histogram, where you can control the observation interval. You can also turn on and off the smoothing filter to allow for better measurements. You can also control the persistence, emphasis, and saturation. And so the user can make all of these different controls, but that can also be controlled through our application programming interface, which what we have observed with customers is that they really like that API. If I come back to the RF, I can just basically turn that off. I have to reach, boom. And that suppresses the control fields, and we're back to the actual display. In the display, I can essentially arm it, and it will then capture data. I can then arm it again, and I can then capture data. So you see basically the data over here is in addition to that, there are status parameters where we give you status on the actual capture band, the analysis band. We give you information about the FFT space that we're doing. You can control the RF record, etc. So it's a very, very robust device. And so, Kevin, looking at the real-time spectrum analyzer, what are some of the things from a user perspective that you admire and like?
This is a highly intuitive tool to create a very complex signal environment, study it, capture this in RF record, and play it back over and over with excellent repeatability to analyze different elements in the spectrum and different formats of what a threat indication may be to an aircrew. We don't normally have these kinds of visualizations in the cockpit, so it's important to have them and test and develop.
Thank you so much, Mr. Greeley.
Thank you, Wade.